This is lesson 2.5 in pre-calc, complex zeros and the fundamental theorem of algebra. So here we go. A polynomial function of degree n has n complex zeros, real and non-real. Some of these zeros may be repeated. All right, so to find the zeros, to find our real zeros, we are going to use Desmos. We're going to graph it, okay? So, well, here's going backwards. So if they give you a function, and it says write the polynomial function in standard form, identify the zeros of the function. So let's do that. All right. So what makes the function 0? Well, the zeros would be 3i and negative 3i. So those would be the zeros, however many things make that 0. There would be 2. These would be non-real zeros in this case. And then to write the function in standard form, we're going to FOIL it. So x times x is x squared, and then negative 3ix and positive 3ix and negative 9i squared. Our middle terms are going to drop, and then that I squared becomes negative 1. So that is the standard form of the equation, x squared plus 9. When you do that, remember that you should not have any I terms in your final answer. All right, the complex conjugate. Complex zeros travel in pairs. So you're always going to have at least 2 of those types of answers. So if a plus bi is a 0, then the complex conjugate is also a 0 of f of x. All right, so this is from the assignment on page 215. This is number 8. Basically, it wants us to, well, those are the zeros. So we will write these in factored form, and we will call it good. So how would I do that? So I have 3 zeros. So if negative 4 is the 0, the factor is x plus 4. Then if 1 minus I is the factor, then we go minus 1 minus I, and then x minus 1 plus I. But when you end up distributing that, you get x minus 1 plus I and x minus 1 minus I. So if you don't put the parentheses on right away, we will just put these in factored form. We don't need to multiply all those out. So those would be the factored form of that, of the zeros. Okay, let's try number 10. Now remember, these travel in pairs. So we have negative 1, 2, and 1 minus I. We also have to put the conjugate on there as well. So we're going to write that in factored form. So that would be x plus 1 times x minus 2 times x minus 1 minus I times x minus 1 plus I. Okay? So 4 zeros, 4 factors. There you go. 14 wants us to write the function, and it gives us some multiplicities. So the multiplicity, negative 1 with a multiplicity of 3, so that would be x plus 1 to the third. And then 3, so x minus 3 with a multiplicity of 1. We put a 1 there or not put it there, and there you go. All right, so this is giving you the zeros and then working to find the equation. And we can do that in factored form. Okay, so I just went through a few of those with you already. And let's keep going. Factors of a polynomial with real coefficients. Every polynomial function with real coefficients can be written as a product of linear factors, each with real coefficients. All right, so here's how we get the all zeros of any function. So this is finding all real zeros, real and non-real. So we got to find the I ones as well. So we can see that this is x to the 4th is our degree. So we should have 4 zeros total when all is said and done. All right, so first thing I want to do to find my zeros is graph that on Desmos to find the imaginary, or the real one. So x to the third plus 5x squared minus x minus 6. All right, and then let's get that back to the home screen. Boom. Right there. 1 and -1. So we found our 2, 0. We always find the real zeros by graphing. All right, so my zeros are 1 and -1 for the reals. Okay? Then you got to use synthetic division. So we know this is to the 4th power, so we have 4 total zeros. We should have 4 total answers here. Well, 2 of them are real and 2 of them are complex with I. So you got to do synthetic division. All right, so you pick either a 0. It doesn't matter. So let's start with 1. And so 1, 1, 5, -1, -6. Then you drop 1, 2, 2, 7, 7, 6, 6, 0. And if you do it correctly, you should not have a remainder. All right? Now, since we have 2 real zeros, we're going to have to do synthetic division twice to get those out of there. So then we got to do it with the other one. And we can use those coefficients that we've already got. We don't need to use the remainder. So 1 times -1 is -1. 1 times -1 is 6, -6, 0. Okay? So that gets us down to our 116. So that means after we divide that out, this is the equation that we have left. Okay? Clear a little space here. Now we can do quadratic formula. We have to do quadratic formula since we have an x term here in the middle. If we didn't, we could just do it algebraically. So I'm going to do, that's 1 and 1. So I'm going to do the opposite of b, plus and minus the square root of b squared minus 4 times a times c, all over 2 times a is 2. Well, that gives me -23 in there. So the square root of -23 would be I root 23. So my zeros then are -1 plus and minus the square root of root 23i over 2. There are my 2 complex zeros, and 1 and -1 are my 2 real zeros. All right, that's how you do 29 in your assignment. So use the real zeros on the graph, then use synthetic division, and then use quadratic formula, or solve it algebraically if you have a term, don't have a middle term like that. All right, I believe that is a wrap for 2-5.